welcome to the third knowledge sharing session of this series, The World of Microservices. So we started with the evolution of software development and software architecture to discuss that how we came to microservices. Then in the second session, in the last session, we discussed the few concepts around microservice, and we saw how a skeleton microservice system can be developed with .NET platform. Now, in this session, we are going to discuss about DAPR, Distributed Application Runtime. This is a new runtime that has been released. It was originally developed by Microsoft using Golang. Now it is open source, and it offers a few advantages that helps the developer to build a more complex microservice system easily. Now, why I chose DAPR for this discussion is that you don't necessarily have to use DAPR in your microservice system. Please note that DAPR is not only for .NET platform. It can be used from other platforms as well. But the goal is not to convince you to use DAPR, but the concepts that we are going to discuss that is very relevant for any advanced microservice system that you will be deploying to the production. Because what we discussed in our last knowledge sharing is the very skeleton of the concept that is used to build a skeleton microservice system. All right. So again, you start with a quote from Maulana Jalaluddin Rumi. So the quote says that we have to try to adapt to the changing world around us. So yes, this is the world of microservices, and like many people in the IT industry, I am also trying to adapt myself to this world. And let us explore what this world has for us in store. So for the agenda, we are going to take a look at the overview of DAPR. Then we will discuss a little bit about the DAPR sidecar, because DAPR is totally maintained and revolves around the sidecar architecture. Those of you already know what sidecar architecture is. It will be a refresher for you. And if you haven't used sidecar architecture, have never seen before, then it will be a good introduction. We will see DAPR service invocation. In our last session, we saw that two types of communications in between microservices. One is the asynchronous communication, another is the synchronous communication. So how the synchronous communication can be done, we saw it. We did it with aggregator, the aggregator calling two different microservices. We also saw the asynchronous microservice communication that happens through a message broker. Here, we will see the DAPR service invocation. I mean, what facilities or what advantage DAPR, this application runtime, offers us in regard to service-to-service invocation. And we will also take a look at DAPR publish and subscribe, which is, of course, publishing and subscribing to and from messages from a message broker. Like I was just saying, there are two types of microservice communication. One is synchronous, one is asynchronous. Okay. We'll also take a look at DAPR state management. Now, There are microservices in the world where state have to be maintained. It's a stateful microservice, although I have never deployed one in production. But there are obviously cases or scenarios where you might need to use a stateful microservice system. And we will also take a look at DAPR actors. Now, actor model has been used or is still in use in many microservice systems or distributed systems where concurrency is involved. There are several teams, I believe, in Cephalo, they are using actor model. So actually in .NET platform, actor model was in the past not very popular, but DAPR is actually offering you a whole actor model framework. Like you have in Akka, I believe, for Java and Scala systems. Similar to that. Of course, .NET had Orleans, but this DAPR actor is actually an evolution of Orleans. So we will take a look at it, how we can do that, and maybe discuss a little bit about actors as well. All right, so let's get started. DAPR overview. So in first class, DAPR helps you to reduce the complexity of developing advanced or more complex microservice system, I'd say. So you see, when you are developing a microservice system, you have to do a lot of plumbing. Suppose you are using a message broker, maybe RabbitMQ or Azure Service Bus. So you have to wrap the API of RabbitMQ or Azure Service Bus, where you implement your event bus interface in that class. You have to actually write code to do that. And also when you invoke service to service and do many other things like store states or cache in Redis or that kind of distributed memory cache and that sort of thing, you have to write a lot of code to make it happen. So what DAPR is offering you, they are offering you a ready solution. I mean, they have wrapped a lot of components inside it to make it easy for you so that you can use this and build this system easily, so that you don't need to write a lot of code, it can be rapid. And interesting is the communication between DAPR sidecars, it happens using gRPC. In case you are thinking about latency, because HTTP, too many HTTP calls offers latency. So DAPR is claiming that it is quite fast. They have taken care of the performance. But well, I can never be sure because I haven't really performance tested this system. Okay, so these are the things that DAPR is offering you out of the box. The service to service invocation, state management, publish and subscribe, even resource binding. Resource binding as in like if you are communicating with a third party, like you want to send out an SMS through a trigger or an email through a trigger. So what do? You generally write an adapter to Twilio or SendGrid. So in that kind of situation, DAPR, if you use DAPR, you don't have to write that adapter because it is offering you by default, and you can easily switch between them. It is also offering you a framework for creating actors. Interesting that it is also giving you the things facility to use observability, which is very important for any microservice system. That you have to be able to track the request traveling from one end to another. For this, since this is a distributed system, it is important. It also helps you, gives you a standard way to store secrets. We'll see how it is all done. when we take a look at the code. So starting with the DAPR sidecar, you see a sidecar comes from sidecar concept, right? So here is your bike, and here is your sidecar. In this picture, there is a dog sitting in there. It could easily carry another man or a woman, of course. That's not the point. So you understand this is the thing used in sidecar architecture. If you're already familiar with it, you know what I'm talking about. So what happens, your service is a very simple example is that your service is running on a container inside a pod. In the same pod, there is a sidecar in another container that collects data or anything about the service that is running inside this container in the same pod and communicates with other sidecars or outside world. We'll see in Docker Compose how that is done. For example, take a look at this here. So how it is happening, this is, suppose if this is a container that is running your service, then this is another container that is linked to it, is actually running the DAPR sidecar. So very easy to deploy a DAPR sidecar actually. You just have to create a container and you don't have to build anything, the image. You can actually download the image from there. It will be automatically done when the container is built. So the DAPR sidecar, it exposes these APIs, these building block APIs, metadata API and health API. What these do, we will see very soon. Building block APIs are for doing all those plumbing things like message exchange, service invocation, that kind of thing. Metadata API is for, it can be used for service discovery and other things. And health API that is used to monitor the health of the system, that kind of thing. We'll see what they are very soon. And now, so far we have discussed a few things. Now you might have started to compare DAPR with service mesh. It is true that DAPR is offering a few things that service meshes do offer. They have some overlapping capabilities, but service mesh is probably more exciting to learn or understand for people who are infrastructure or they work in infrastructure or DevOps. DAPR, on the other hand, is mainly for developers. It helps you to simplify the plumbing, but it actually mainly for developers. From here, you can take a look at that where service mesh and DAPR overlaps, and what is very specific to service mesh and what is very specific to DAPR. Yeah. This MTLS matrix resiliency and distributed tracing, it is generally offered by service mesh and DAPR as well. So MTLS is probably a very important technology that is in modern days, like when two services communicate between each other. And I personally haven't used it in production. The mutual authentication thing that you use in the zero trust environment. In the last knowledge sharing session, we discussed that how service to service communication can be done securely. We had a little bit of discussion about it, that we discussed that we can reuse the token from the context, but that's not a very secure way to do it. Then we also discussed that we can use an agent that before calling another service, it will get the token from the identity. Of course, you can also use API keys, which is used in some system. Or you can, if you are using gRPC, you can use auth0 client protocol to get token and everything. But then again, you can also use MTLS, which DAPR is offering. The metrics and resiliency, this we discussed about it, like how you have to build resiliency in your microservices, fail safe or retry or circuit breaker, that kind of thing. It is also offering distributed tracking. We'll see slowly. So this actually here, it is showing you that where service mesh and DAPR has common things, common services they offer, and where it is different. So it's actually not same, although it has some similarity. Service invocation. So when we invoke service-to-service communication, that as in like the synchronous communication between microservices. So if you recall from our last knowledge sharing session, we said that actually service to, like if there is a microservice A and there is a microservice B, direct synchronous communication between them should be avoided. Yes, that is true. But still, you need to use the aggregator from time to time that calls multiple microservices to get a reply or to replicate data. So, and also sometimes you need to call external microservices or external services for getting information. Or like you, of course, have developed microservices for messaging, like sending message to SendGrid or Twilio that will end up in an SMS going to client or an email going to customer. That's quite common. So those are also service-to-service communication. Sometimes they need to be done synchronously. So DAPR is claiming that they offer a few things like service discovery, standardizing API calls, or secure inter-service communication using MTLS. And they also offer you facility to develop these timeouts, and it gives you observability. How it is done, we'll see when we take a look at the code. So this is something I wondered, that service discovery is generally available in Kubernetes cluster. Okay? Like when you deploy your microservices to Kubernetes, it already offers you several things through which you can manage service discovery, like the service itself, and then the DNS and the ingress controller, this selector label, that sort of thing, in the Docker Swarm, it is a little different, but it has similarities. So why do you need service discovery? So then what people told me that this thing is platform independent. So therefore, if you are deploying on a platform where this service discovery or standardization or secure communication facility is not available, you can still go ahead and use what DAPR is offering. But this example I have developed, it is running on Docker Compose, so it is pretty straightforward. You know how the Docker has the named server that lets you like discover services automatically. But if you ever use it in a system where the service discovery things are not available, maybe you can try it. Anyway, so the standard service invocation happens like this. Suppose this is your service. The service first sends a call to its sidecar. Then the sidecar relays the call to, it resolves the component and everything. Maybe this is better. Yeah, this is better. It uses the name resolution component, then calls this other sidecar for which this request is indexed to. Now this sidecar then calls service B. Service B replies and it goes back through the sidecar again. Now, this sidecar to sidecar communication, it happens using gRPC, and service to sidecar communication can happen using gRPC and HTTP port. Now, here you see that two sidecar are communicating using the MTLS encryption. This is supposed to be a very secure thing, but I don't know if you are able to break it or not. I personally have never tried. So how MTL, mutual authentication, offers, that's a very big topic. I'm not going to discuss it here. If you're interested, I can send you a link, or you can send questions where I'll try to answer. Right, so the DAPR bindings, bindings are actually pretty straightforward. It offers you that some integration, like we were just talking, that suppose in your microservice system, you need to receive a message from an external service, like maybe Twitter or something else. So in that case, you have to do what? You have to develop a special API, you have to develop polling system, you have to develop adapter, a lot of things. But DAPR is offering you components out of the box. It has two types of binding, the input binding triggers. It works pretty much like that. Again, the sidecar is involved. The sidecar already has all these components. You can simply write a binding configuration, and then your service can subscribe to it. And likewise, the output binding, when you are sending message to a third-party system like Twilio or SendGrid, you don't have to write the adapter for Twilio or SendGrid. It is in your sidecar. You simply call the API, the message will go. We'll see how it is done. Because in my last project as well, I had to write adapters for calling Twilio and SendGrid. So there is some work involved in there, because you have to actually wrap the API code and everything. This system actually makes it easier. DAPR publish and subscribe, this portion I find it most interesting. Like I was saying, last time we saw that when we were publishing a message in RabbitMQ, I showed you how I wrote my event bus implementation in a class where I wrapped it around the RabbitMQ interface. Now, suppose we are using RabbitMQ as message broker, and 3 months later, the team decided that we will not use RabbitMQ anymore. We will move to a more powerful one, or simply a different one, like Kafka or as a service bus. So in that case, what I'll have to do, I'll have to write another implementation of that interface with wrapping a class, wrapping around as a service bus, or in case Kafka. But in using DAPR is much easier. You actually don't have to do any of it. You simply have to change the configuration file and it's done. We'll see how it is done. It's quite interesting. Also, you don't have to register those event handlers and everything. You can expose a controller and subscribe to events. DAPR sidecars, and they will take care of other things. So this is what it is calling, that we are providing you out-of-the-box implementation. So what happens? An abstraction is made on the top of this whole thing. It's very easy, actually. Okay. So this is how it works. DAPR has this publication subscription components where these Redis, Kafka, and other things, I mean, all sort of like most popular message broker systems, they have already developed component and created abstraction. All you have to do, you have to create a configuration file, and then you can simply use it. We'll see very soon how it is done. It's quite interesting, actually. Okay, this is the publication subscription, observability. So in most modern microservice systems, you need to trace your events from here to there. Like it is traveling from where. So you need to see it. It's easier to understand and see the health of the API and everything. So DAPR is also offering you some out-of-the-box solution, and how you can use them, we'll see. Together with Zipkin, you can collect things. Let's take a look at this. Probably will be easier. So what happens that every time the service and sidecar communicates, the sidecar collects the data about the service. It's about the health and also the tracing of the API calls. And then it can publish this data to a monitoring backend. So this monitoring backend can also be Prometheus. I mean, anything famous. DAPR has already created this integration component and everything. So you actually do not have to develop a lot of things on your own. So we'll see how it is done very soon. So this goes about observability. And state management, again, for state management, like maybe many of you have already used Redis or this kind of distributed memory cache for state management. DAPR makes it easy. You don't have to create the adapter and anything. You can simply create the configuration YAML and use this to store your state in a state persistence store. Now, another thing why the states are important, because if you are implementing actor model, the actors have state, because it cannot function without the state. That's why, I mean, it's also important, the state management. An example could be like the shopping basket. It's an example for the stateful web services. I mean, sometimes you might need to build stateful web services. Although I personally never have. I have never actually built a stateful web service, but in some cases it might be necessary. But what I found most interesting is that the state together using, you have to configure state management in case you want to use the actor model. The actor model must use the state. So this discussion about the CAP theorem is actually, I mean, relevant to developing any microservice system. It's not only using DAPR. Like these three things in any distributed system that we need to deal with: availability, consistency, and partition tolerance. So let's take a little bit about what are they. And I mean, if you have implemented microservice system, you already know about it, but maybe do not know the theoretical terms. So this is a theorem that states that a distributed system cannot be CAP. When you are developing a distributed system, you cannot have consistency, availability, and partition tolerance at the same time. That is what the theorem states. So you must maintain P property, that's the partitioning tolerance, and choose between AP or CP. Now, DAPR claims that they actually have very good support for both models. Now, if you take a look at the, I mean, if you are an experienced microservice developer, you already know what it is talking about. But if you are a bit new, so let's take a little time to understand what this AP means when you are choosing availability over consistency. But what actually happens? Where you will get a performance hit, right? And if you choose CP, where it happens, what happens, and how it is relevant to your simple implementation. So one is happening what? First, you are storing in the status store, then it is saying that the status store will asynchronously update all the other data nodes that we can relate to the event subscription and that kind of thing here, but there is a delay there. So it, I mean, the availability of the data is not so much, because if someone sends a GET request and the data is not replicated to the node, it will reply with the latest data. On the other hand, this strategy AP will make sure that your data is replicated to all nodes, then you return the call, but that will hit performance. Okay. So I will not worry about the CAP theorem that much, because when you are doing hands-on microservice implementation, you have to think about this problem and you have to decide very carefully, because in the last knowledge sharing session, we saw that the synchronous communication and asynchronous communication is both very important. So when you are replicating data from one node to another, these both models are important, but you need to understand that what you should apply where. Okay, that is the thing from your business scenario, what should apply where. That is the most important thing. So if you have already used actor model, then you already know about it, that how the actors work. The actors are actually, this is a way that you do not have to lock your resources inside. Like what happens when there are multiple concurrent calls and there is a concurrency thing. So what you will have, first you will start locking things like using a multiple thread, right? You lock the resource, one thread executes, releases it, then another thread comes in and locks it. Like you synchronize, exchange this locks like this for some time. It's locked by this, then that. Actor model, on the other hand, it is built around the idea that it implements this turn-based access model. So turn-based access model says that if an actor is receiving multiple calls, they're not really calls, they call it message. I mean, you cannot directly call an actor, you send message to it. So when it is having multiple messages, only one message, I mean, within one method, only a single thread will run at a time. So this way, you don't have to lock the resources. So that is, I mean, if you can take a look at I have also discussed with the developer who is very experienced in akka actor model used in, they also maintain it in the same way. So DAPR is offering you this whole actor framework where you can simply, very easily create actors and manage it. It also gives you this, this is how it is done. I mean, the placement of the actor on different nodes, you don't have to worry about that as well. I think most other advanced actor placement modules and frameworks also do that. So here they are doing the same thing. You don't have to place the actors on separate nodes or pods when you're running it on the Kubernetes. It has a placement service. The placement service will do it, and you simply have to consume it. And its life cycle, when it will start, when it will be destroyed, everything will be maintained by DAPR. But anyway, it's very important to understand that when not to use actor model, because it's not for everything. Huh? So when you are developing things, this orchestration-based Sega or process manager design pattern is a good fit, but it's a low latency system. So you have to be careful where you are using it. Actor life cycle. Yeah, so I'll discuss a little bit about actor life cycle, how actually, because I think it might be a little different from Akka. Although I heard that Akka has a basic module, then the advanced module. The advanced module is pretty similar to what DAPR is doing. So what happens is the actor is placed on a node, activated when the first call comes in. Otherwise, and then it has a configuration time that how long this actor will leave unless it receives a new message. When no message is coming in, how long it will leave, and then it is deactivated, destroyed by the actor placement itself. You don't have to destroy the actor by sending a message or writing code or something. It does it like pretty self-managed. But of course, like if you want to clear out the status store from the actor's state, that you can do something during the deactivation method. Now remember that cleaning up the actor's state is not always the good idea, because I have spoken to other actor model developers as well. Because the actor actually have the state, because why do we maintain the state? Because the next time the actor wakes up, so that it has access to that state, right? But so you have to be careful about that, like if under what condition you're cleaning up the state. So that was pretty much about it. Now we will go ahead and take a look at the code implementation. So first, let's take a look at my container orchestration. Should be full screen. So I'm using Docker Compose for container orchestration. It's pretty straightforward. Like every microservice is hosted on one container, and it is together with a sidecar. So this is my container description. It exposes this port, and it is depends. But my sidecar has the definition here that it is this service's sidecar. And the image is, I'm using 1.7, but you can choose to use the latest. The network mode, this network mode is important, but there's a lot of discussion here. Simply suffice to know that you have to mention the network mode here. And this is my DAPR placement. DAPR placement does what? It places these actors and everything and keep tracks of these sidecars. So now you understand that if we take a look back at this thing, our sidecar picture, this is the service, this is the sidecar. Likewise, here we have the orders API and its sidecar. Likewise, the payment API has the payment API sidecar. So every microservice is accompanied by a sidecar. Now, you might be wondering that what happens if we have multiple containers in a pod for a service, right? Because in a Kubernetes cluster, you might be running multiple container on a pod. So will we have multiple sidecars? Actually, no, you'll have a single sidecar because those pods still will be running on the same service. So then will be using Ocelot as my gateway. And I'll show in Jipkin that how this service-to-service communication can be traced. So, right, let's take a look at it. So I'll send a post request to my orders microservice. Like last time, again here, I have two main microservices running under the API gateway. And I have the aggregator. I have orders management, payment management. I also have basket management, but it's actually is not be communicating with other microservices. So main two microservices, order management and payment management. So I'll send a call to my order management API using a simple post, this. So you see, this is my upstart order command. We saw in our last knowledge sharing session that how you can use CQRS and together with the clean architecture and mediator to implement the command handler. So this is the same thing happening here. It will publish an event to my message broker. Now, what is interesting is let's take a look at my event bus implementation here. So recall from my last session that in my last session, when we saw the event bus communicating with the RabbitMQ, I actually had to implement it in a class, right? This class is written around the RabbitMQ API. But here, when I'm using DAPR, I don't have to do that. I simply have to write this abstraction and my events and extension and everything, but actually I do not have to write the actual implementation. Now, this is I have, but I am not using that event bus RabbitMQ here. This has no use. Why? Because I can do this simply by using a DAPR component, PubSub component, simply by writing a YML file. Now, once I have written all these component YML files, then I have to make sure that my DAPR sidecars know where this is. For that, if you take a look at my override, in the override, I'm actually mounting this component and configurations in the container volume and letting it know that what are the details of it, like where is my placement service, what is the app ID and everything. It's all goes here. So, okay, so let's go back to the code because this is boring stuff. My call came in, I release it. So now you see that I have received this on the payment API. So what is happening? The order API is creating the order in the database. Here, I have two independent databases running on the same server, but they are independent for payments DB and order DB. So it has been created. Now, at the same time, the call goes to, an event has been published by event bus to a message broker, and the payment is actually subscribing to it. Now, how it is subscribing it? Recall from the old code that when the payment service used to subscribe to RabbitMQ, what I needed to do, I needed to write a configuration. Inside the configuration, I had to tell to the microservice, I had to register my event bus, of course, but also I had to register my handler. And also I had to tell the microservice, I have to actually register that to which event it will be subscribing and what is the relationship between it. But in the newer system, you don't have to do any of this because you do it through this integration controller. The integration controller actually has this endpoint. You know what? Actually, you could simply handle the event. You don't have to write the event handler. I wrote it to just show you the separation of code logic, but you could handle it here in this method. And to do this in the programs, I do not have to write a configuration. In the event bus configuration, you see, it's much simpler. I have only registered the handlers. If you are writing the code to handle this event and everything within that method, you don't even have to do this. So mainly it is done through here. This default controller and matrix controller, and you have to add in the middleware this actor and everything. The DAPR has a very nice documentation on how you can do this. You have to add this DAPR client to the controller. So what this does, the DAPR client is pushed into the controller. So you see, it's so much simpler. Now, here in my payment, let's go back to my handler. Now you see, I'm calling the service. This is the service method. The service method will do what? The service method will create a payment. At the same time, it will invoke an actor. It will send a message to an actor. Now, this is my actor. Now, look, this is not a perfect implementation of an actor. I'm simply showing you that, and it's much more simplified. I'm simply trying to show you that how an actor can be written. So what is happening here? The call came into the actor through a proxy. Now the actor will create a state for this payment. Now, why the state is important? Because, it's a simple logic in actor model is that every time you try to update a state, you actually check the previous state. So there is a logical relationship between. Simply put, like if an payment has been paid, cancelled, you cannot pay. You cannot set the state to paid, right? And when a payment has been paid, you cannot set the state to cancel. I'm just trying to explain the relationship to you guys. there might be a lot more complicated relation with it. Anyway, so what happens? It simply creates an actor. Now let's take a look. My order has been created. Payment has also been created. I check my databases. Yeah. Okay, my payment and my order has been created. Both are status new. The payment is not paid or not canceled. So what I will do now is this. So suppose I want to cancel the payment. So what will happen? If I cancel the payment, the call will first come into payments controller. Here. So then the controller will try to get the actor, right? So it is sending message to the actor that cancel the payment. So once the payment has been canceled, what will happen? The actor will publish a message event. Now, if you take a look that this event has been subscribed by both microservices, the payment microservice and the order microservice. So payment microservice is doing what? Subscribing to the event and updating the status of the payment in the database by calling this payment service. It is setting it to cancel. And what the order service is doing, it is also canceling the order. At the same time, it is sending a message, a SMS, to the administrator who has this number. Hey, this is not a good implementation. I mean, I just did it, especially like this part. You should never hard code things like that. But what I'm trying to show you that at the same time, it is using this DAPR binding to send a message to Twilio. So you see, I haven't written any adapter or anything for implementing this. It can still work. So how can it work? I can simply write this state store by doing this. And I can use the send message to Twilio just by putting this configuration YAML here. This is my secret store, but you can it is important to store certain secrets in a secure way, like password. Sometimes you put it in the configuration. This is the secret store that DAPR is providing. So app secrets is also here. Password can work like that. So yeah, this is pretty much it. Now another thing is the service invocation. Sorry about that. Now let's take a look at the Zipkin. So this is how you can see the traceability. I mean, if I take a look at this. Yeah, so how the aggregator is calling the payments API and order API and everything. It is actually showing from where the message is traveling. Very interesting, right? And for the matrices, you can use plug it with the Prometheus or any other interesting thing. Can you all see the Zipkin?
Yes, we can.
Okay. Yeah. Sorry, I think there is a network delay or something on my part.
No, we can see it.
Okay. Great. So yeah, that's pretty much it. And in the service invocation, I have done service invocation only in the aggregator. Let's take a look at it. So I used a DAPR client that is actually part of the DAPR library. You can use this directly to invoke the method, but this implementation actually cannot show you the real potential of service to service invocation. I guess you have to try it in a real clustered setting like Kubernetes or something. But regardless, this method will work. I mean, it will, even if there is not a service discovery system present, DAPR said that it will work, but I haven't tried it. So I guess if you want to do it, you have to try it yourself. Okay, so we will go to the question answer section now. I am pretty much at the end of my presentation. Yeah. Any questions? Anyone?